So your test is next class. Geo, if you have missing assignments, you can hand them in today if you want. If you want to hang on to them to study from, I'm also fine with that. I am going to send an email update out probably tonight so you can let your folks know if you have some missing assignments and they're saying, well, how come you got some missing assignments? You can say, Mr. Duick said I could hang on to them to study from, show them you got them done, and we're good with that. As you know, I don't take marks off for lates. The consequence for not doing the assignment is you're going to do the assignment. It's just how painful you want me to make it. Our senior boys play today, right around noon. Come to the game, support our boys. So we got Gio, we got Tato, we got, not here today, but okay. Define acceleration, and is acceleration a vector for two, oh, you have to do my favorite student, Mr. Duick. First of all, the second part, is acceleration a vector, yes or no? Yeah, the direction absolutely matters. In fact, it makes the difference between speeding up and slowing down, depending on whether your acceleration is in the same direction as your velocity or in the opposite direction of your velocity. Define acceleration. There's many ways to define it. If you said change in velocity, that works. I had somebody say, I said it was VF minus VI over T. You gave me the mathematical definition. I'm good with that. I had somebody say, Mr. Duick, isn't it delta V over delta T? Sure, I'd take that. Did anybody say anything else? You can ask, and I'll probably give you credit for it. Okay, so 2 marks for anything along those lines. Acceleration, you'll find, is actually going to be a key concept when we look at forces as well, when we talk about Newton's laws of motion. If an object is changing its velocity, there must be a force acting on it. Yeah?
Acceleration is the rate at which something speeds.
Sure. By the way, if I was being fussy, or slows down. But that's why the more generic term would be acceleration is the rate at which an object's speed changes, velocity changes. Sure. An accelerating body must at all times, circle the best answer, have a positive velocity, have an increasing speed, have a changing, you know what? It's changing velocity. Because you can be accelerating and slowing down. In English, we call that decelerating. In physics, we just say it's a negative acceleration. All right. State whether your velocity is increasing or decreasing for each of the following situations. I'm going to use an I for increasing, and I'm going to use a D for decreasing. For some of these, there is more than one answer, but I will only accept that answer from you if you can give me the situation in your mind that you were thinking of. Say, what? If your velocity is positive and your acceleration is positive, I think everybody there probably said your speed is increasing. Your velocity is increasing. If your velocity is positive, I'm going to think forwards, and your acceleration is negative, I'm going to think backwards. What would you say here? Okay. Yeah. Sure. Decreasing. And that's my standard go-tos are cars, and if it's up down, honestly, I go to the elevator is a good one, or free fall. Your velocity is negative, you're in reverse, and your acceleration is positive forwards. Increasing or decreasing? This can be increasing. If you said increasing and you want to convince me that you're right, I will accept your argument right now if you said increasing, but you'll have to convince me that you're right. Did anybody say increasing? And usually it's a math nerd who's really pedantic. Talk to me. Why?
If you're going backwards, your velocity is negative and your acceleration is positive.
And so if your acceleration is positive, those negative numbers are getting less negative, which technically means they're increasing because -4 is a bigger number than -6, even though we think that 6 is a bigger number than 4. Negatives behave if you thought that, I will accept increasing from there, and I will also label you as pedantic math nerds. Yes?
Maybe you're speeding up backwards.
If you're speeding up backwards, but then if you're speeding up and going backwards, what direction would your acceleration be? So I would not accept that from this one. Okay? Velocity negative, acceleration negative. That's, by the way, D, that's what you're talking about. And I think most people would say that your velocity was increasing, but if you were a pedantic math nerd, you would say, wait a minute, those are negative numbers that are getting further from zero, and a negative number further from zero is a smaller number on the number line, and so you could say that it was decreasing, and if you thought that and said that, I'd live with that. I've thought about changing this question. It was this way for a while. It's been this way for a few years. I leave it this way to have the discussion about just be aware that negative numbers behave a little strangely. If I had said speed instead of velocity at the very top there in the instructions, then all of these answers would be the way they are, no exceptions. But because I said velocity, I'll live with that. Hey, what does the slope of velocity versus time graph represent? That's from last unit. Yeah, you still got to remember stuff. That's all fair game. Alrighty. What's its acceleration? I got Geo yawning. We got a shorter class. I'm going to cut corners. I would normally defic list my data. I'm going to go straight to saying, you know what? It's going to be A equals VF minus VI over T. That gets you 1 mark. It's going to be 5 minus 25. We're slowing down. I'm going to get a negative. All over 8, that gets you 1 mark. It's going to be 20 divided by 8, negative 20 divided by 8. I can do that in my head because it's negative 10 divided by 2. Is it negative, negative 20 divided by negative 10 divided by 4. Is it negative 2.5? And then meters per second squared. As always, 1 mark, half mark, half mark. Did I give you one somewhere in this quiz in kilometers per hour? No, somewhere on your test at least once I will give you the speeds in kilometers per hour because cars. So make sure you do the conversion. It's something to do with the 3.6 and then do the physics. Okay? I'll probably give you a hint because I'll probably make that question worth 3 marks because there's an extra step. Maybe not. Can't remember. Oh, I did put one like that on your study guide. Average acceleration. A equals stops. So we're going to use VF minus VI over T. Stops means 0 minus 30 all over 6. So you get negative 5.0 meters per second squared. Is that right? Why did I say average acceleration? Well, it took 6 seconds to stop. I'm hedging my bets. Maybe the bus driver didn't press the brakes consistently over those 6 seconds. It might have stopped quicker at the beginning and slower. I don't know. So whenever I throw that word in, it's me as a physics nerd, Gracie, just saying I don't necessarily know that the acceleration was exactly negative 5 the entire 6 seconds the whole time. That's me being a nerd. Looks like it wants V final. I think I can go equals V initial plus AT. It's going to be V initial 103 pretty fast plus A. Why did I write a negative 5? You're right. Oh, we got a latecomer coming in. Someone late on late start day. Oh, boy. So, yeah, negative because we're slowing down. If you miss the negative, you'll lose a half mark. So I get 103 plus negative 5 times 7.5. I get 65.5 meters per second. If you miss the negative, if you got 140.5, I'll give you 1.5 out of 2. Same as before, 1 mark, half mark, half mark. And we turn the page. Oh, up here also, 1 mark, half mark, half mark. How long? T equals V final minus V initial all over A. Final, 10, minus initial all over 3.5. 8 divided by 3. That doesn't work out nicely. 10 minus 2 divided by, and it didn't say we're slowing down, so A is not negative. Do you get, sorry, to go from 2 meters to 10, V final. Oh, I put a negative in for some dumb reason. I said A is not negative, and I put a negative in. Let's try that again. Do you get 2.285? Oh, I guess 2 sig figs. I'm going to go 2.3 seconds. Also, as always, if you have the wrong units or missing units, half mark off. Okay? Alec, follow along with us and get the ones that you missed later on. That'll be better learning, I think, yeah? What must your initial velocity be if we accelerate? Final velocity, you know what? V initial is V final minus AT. Haven't pulled that one out very often, but I think if I got the VI by itself, that's what it would be. Yet another equation. Yet again, Nick, don't memorize them. My way is better. V final is 20 minus 3.2 times 3.3. 20 minus 3.2 times 3.3. Do you get 9.44? Technically, I should go to 9.42 sig figs because of the 3.2. 3 marks. What does 3 marks mean? Probably going to be an extra step. Oh, I gave you a hint. I might not give you this hint on your test. It says, find A first. I'll cut my question in half. It says, I want to find A first. I think I can find A by going V final minus V initial over T. After 30 meters per second, it starts out at rest. After 12 seconds, I think the acceleration is 30 divided by 12. Divided by 6, divided by 6, 5 divided by 2. Is it 2.5 again? Yeah. Now I can find V final, which is going to be V initial plus AT, where V initial is 0, still starts at rest, plus an acceleration of 2.5 and a time of 7.5. Now I can find V final. It's going to be 0 plus, what did I say? 2.5 times 7.5. Do you get 18.75? I'll go 18.8 meters per second, but 18.75 is right. Is that right? How many of you got that? A little two-stepper. Nice! Nice. How many of you would have got that if I hadn't given you the hint? That's a hint, by the way. I might not give you the hint in the future, okay? The way I would mark this, I would give you 1 whole mark for finding the acceleration, and then 1 mark for the equation, half mark for the answer, half mark for the numbers. What I really mean by that also is, let's suppose you didn't know how to do this. If you had made up a reasonable value for the acceleration and wrote a note to me, I would still give you 2 out of 3 if you could find V final. For all of these, we want V final equals V initial plus AT. So it's going to be V final equals 0 plus negative 9.8 times 2. I think for answer A, you get negative 19.6 meters per second. Yes? And I think for answer B, you're going to get 0 plus negative 9.8 times 6. You're going to get negative, oh, I can do that one in my head as well, because negative 10 times 6 is negative 57.6. Negative 57 point, no, I'm off. Maybe I can't do that in my head. 58.8. I forgot to carry a 1. Yes? Negative makes sense, because we are going down. Number 12, how long? Okay, now I'm going to go for all of these, T equals VF minus VI over A. It's going to be T equals negative 24.5 minus 0 all over negative 9.8. Negative 24.5. You know what? I don't need to type the minus 0. Divided by negative 9.8. 2.5 seconds? That's for A, and for B, it's going to be negative 63.7 minus 0 divided by negative 9.8. 6.5 seconds. I made these work out nice. I might not bother doing that on the test. On the test, you might get a yuckier decimal here, okay? Question, Rick? 11.
2,
Sorry? Number 11, A or B?
8.
A?
So I think the 2 should be squared.
No, it's VF equals VI plus AT.
Oh.
It's not D. I didn't say how far. By the way, you know where the squared's going to show up? Number 13. Good preview of coming attractions. In number 13, for all of these, I'm going to use D equals a half AT squared. It's D equals VIT plus a half AT squared. VI is 0 because we're dropping. So it's going to be D equals 0.5 times negative 9.8 times 2 squared. 2 squared is 4 half. Here you get negative 19.6 meters. Okay? And it happens to be, by the way, the distance that you fall in 2 seconds by a wonderful fluke happens to be your velocity after 2 seconds. Just the reason is because 2 squared is 4, and when you take half of 4, you get a 2 again. It's just a fluke, but kind of cool. I don't think the answer for 6 seconds is going to be negative 58.8. Maybe it will be. It's going to be D equals 0.5 negative 9.86 squared. 0.5 times negative 9.8 times 6 squared. I get negative 176.4, is that right? Yeah. 2 marks for each of those, as always. 1 mark for the equation, half mark numbers, half mark answer. I chose to only write the equation once in the interest of time. On the test, I'd probably write it out each time because, you know, nerd. And now we turn the page over. Anybody here been to the CN Tower? I have not. No. To the top of it as well?
Yeah.
Can you, from that height, start to see the curvature of the Earth? I don't think you can, but you just get a good view. Yeah? Okay. It's on my list of things to check out. How long? Well, T is going to be... Oh, wait a minute. I'm going to start out with D equals a half AT squared because VI is 0. This one's complicated enough that I'll show more steps, Ira. I think T is going to be the square root of 2 times D over A. Or some of you, instead of a 2 on the top, would have a 0.5 on the bottom because dividing by a half, same as timesing by 2. In fact, Geo, this is the same as the physics of the reaction time little mini lab that we did. It's going to be 2 times 533.3 divided by negative 9.8. I've made a mistake. Because if I go 2 times 533.3 divided by negative 9.8 and I try square rooting that, I get an error. I heard somebody say negative. What's my error? The numbers that I've put here have told the universe that I accelerated down but ended up above from where I started, which can't happen. I love the fact my calculator says non-real answer. The universe is saying, hey, dude, get real. I kind of like that. It's not quite what it means, Sasha, but I like to think of that. So there has to be a negative there. Some of you, by the way, I've gone on my rant about good calculators. Some of you might have a calculator that certainly lets you backspace 1 line, but it might let you backspace numerous lines. If you have the manual, it's worth reading and finding out. It's handy. And square root of this, it's going to be a little more than 10 seconds. 10.4? Is that right? I think a couple of years ago, I think for New Year's Eve or for Canada Day, a stuntman did a free fall on a stuntman line from there where he fell most of the way and then got slowed down at the last second. But they have to slow you down very carefully because if they slow you down too fast, too big an acceleration, too big a G, you snap your spine. So it was a very, very complicated stunt, but they did do it at the... So I think he fell for about 7 seconds of free fall before they started to get slowed down. That's a long time. How fast? This one's V final. I think, although I could use time, I think I'm going to use VF squared equals V initial squared plus 2AD and then take the square root. I'm going to go 0 squared plus 2 times negative 9.8 times negative 533.3. If I had used VIT plus a half AT squared, I would go 0 plus negative 9.8 times time. You'd get that. Now I'll do it the other way, and you'll notice we get exactly the same answer. If I go 0 squared 2 times negative 9.8 times negative 533.3 square root of that, except what do I have to remember to add in front of my answer here? I have to include the negative, and I have to just do that myself. Negative 102 meters per second. 15 was a curveball. 3 marks. You've never given one like this, but I'm not going to freak out. I can handle this. It wants me to figure out how many times further something falls in 10 seconds than in 1 second. That falls. You know what? I'll figure out, first of all, how far it falls in 10 seconds. I'll call that D10. And I think that's going to be a half AT squared. I'm going to assume, since they didn't give me a VI max, I'm going to assume we dropped it. I'm going to get 0.5 negative 9.8 10 squared. And I get 490 meters. Then I'm going to find D1, the distance in 1 second, which is going to be 0.5 times negative 9.8 times 1 squared. This one I can do in my head, because 1 squared is 1. Times negative 9.8 is negative 9.8. Really, this whole thing works out to half of negative 9.8. I think it ends up being negative 4.9 meters. By the way, this will get you 1 mark. This will get you 1 mark. How can I figure out how many times bigger my first answer is than my second answer? What will you do with those two numbers? Huh. Sarah? Divide them. In fact, here's what I did. I said, when I don't know what to do, I always do the same question, but with easy numbers. I said, let's suppose you have 20 bucks. I have 5 bucks. How many times more do you have than me? I think 20 divided by 5, you have 4 times more than me. I've fallen negative 490 meters. I've fallen negative 4.9 meters. How many times bigger? Final answer, negative 490 divided by negative 4.9. And what do you get? Is it 100 times farther? Yeah. My abbreviation for 100 times, I write a times sign. I don't know if that's proper or not, but I'll go with that. That also gets you 1 mark. V final equals V initial plus AT, I think is what you're going to use here. 0 plus 1.1 times 6.5. You could have let, since it's downhill, you could have let the 1.1 be negative and you'll get a negative velocity. I didn't get that fussy because downhill is slanty. It's not straight down, so I'm willing to say the truck's going forwards, whatever. 1.1 times 6.5. Do you get 7.15? And I would take a negative 7.15 here as well. How far? D equals, you know what? I'm going to use VIT plus a half AT squared, although VI was 0. I shouldn't have bothered writing that. The acceleration is 1.1, 6.5 squared. 0.5 times 1.1 times 6.5 squared. Do you get 23.237? I'm going to go 23.2. Is that right? And this would be meters. You could also have found this by going D equals VF squared minus VI squared all over 2A. You could have gone VF squared, your answer from part A squared, minus VI squared all over bracket 2 times 1.1. I would not do it that way, but if I had time later on in the test, I would do it this way, and the fact that I get exactly the same answer tells me my answer A must be right because I got the same answer on B without using answer A. Yay! How many marks is this question? Probably 2 steps. Let's see. They want me to find time starting from rest. Okay. It looks like I'm going to go t equals Vf minus Vi over A. And it looks like Vf is 16, Vi is 0. Oh. Oh. Do I know the acceleration? No. So even though this question wants me to find time, you know what I'm really going to have to find? Acceleration. It's a 3-marker. It's a 2-stepper. So I'll do that over here. A equals Vf minus Vi over T, where Vf is 9.9 minus that over 1.8 seconds. 9.9, I guess I don't need to go minus 0, divided by 1.8. I get an acceleration of 5.5 meters per second squared, and that answer can go right there. And I'll end up getting 16 divided by 5.5. Do you get 2.909? So 2.91. Heck, 2.9 seconds. If you got that, 3 out of 3. Otherwise, I would give you 1 mark for that, half mark for that, half mark for the answer. I would give you 1 mark if you had found the acceleration successfully. An aircraft starts from acceleration. I think I can go V final minus V initial over T. I don't need to use the other one. It's going to be V final 48 from rest divided by 12. 48 minus 0 divided by 12. Do you get an even 4.0 meters per second squared, or just 4? Really, I should go 4.00 because it's 3 sig figs, but 4? Yes? No? Yeah? How fast is it moving? VF is going to be VI plus AT. I think that'll work. It's going to be 0 plus 4 times 16. I can do that in my head. 64 meters per second. How far? D equals VIT plus a half AT squared, although VI is 0. It's going to be 0.5, 4 times 15 squared. I don't think there's a way to do part C only using information they gave you. I think when I tried to do it with any other equation that had a D in it, I was using something that I'd calculated, so I just said, oh, for Pete's sakes, I'll use the one that has the D by itself already because it's less work. 15 squared is 225 times 4 is going to be 550 times 1,100. 550, is that right? 450, that's what I said. 450?
Yeah.
Yes! 450. This time I carried a 1 when I didn't need to. Sheesh. Once the acceleration, I have V initial, V final. Okay. A equals V final minus V initial all over T. It's going to be 10 minus 15. We're slowing down. I'm going to get a negative answer. Going to be 10 minus 15 divided by 3.25. I get negative 1.5384, negative 1.54. Is that right?
Yes.
I will be fussy. Negative 1.54. If you wrote negative 1.53, I'm taking a half mark off, and I'm saying learn to round off properly, please. Number 20. A motorbike rider traveling 42 meters per second collides with a haystack and his average acceleration. Okay, they gave me a distance, V final. Oh, A equals VF squared minus VI squared all over 2D. It's going to be 0 squared minus 42 squared all over 2 times 5.7. You may have seen these if you're watching sports or on YouTube, the street race motorcycle guys in their leather, they'll skid along the pavement and then they often collide into a hay bale to bring them to a stop. Why? Well, the hay bale lengthens the distance. The bigger you can make this number on the bottom, the smaller the acceleration will be. And it's acceleration which does damage in car accidents. We've talked about G's and G-forces and things like that. So 0 squared minus 42 squared divided by 2 times 5.7. 5.7, Mr. Dewick? Do you get negative 155? Yeah? This person would be in pretty bad shape. They probably would survive because typically the motorcycle riders are wearing extra padding and a helmet, unlike, say, a driver of a car. So, but they'd have some pretty serious damage, and there's a chance they might not survive this. How many G's is that, by the way? How can I calculate that? Yeah, 16 G's, that's survivable, but you're in the hospital, almost certainly. Okay? Last one. On August 19th, 2015, a world record cliff jump was set by jumping from a height of 58.8 meters into water. How fast was the jumper traveling when he hit the water? V final is going to be V initial plus AT. No, I can't use, I don't know time. V final squared is going to be V initial squared plus 2 AD. How to get rid of a squared square root? It's going to be 0 squared plus 2 times negative 9.8 times negative 58.8, because he most definitely ends up below from where he started, and then square root that answer. 2 times negative 9.8 times negative 58.8, square root of that. You get 33.9 meters per second, 34 meters per second. Yes, thank you, negative 33.9 meters per second. If you missed the negative, a half mark off. 1 mark, half mark, half mark. That's pretty fast, by the way. How long was the jumper in free fall for? You know what? I'm going to go use my answer from part A. I'm going to go V final minus... No, I don't need to. Wait a minute. I could go T equals the square root of 2 times D over A. That'll work too. I can do that. It's going to be the square root of 2 negative 58.8 all over negative 9.8. 2 times negative 58.8 divided by negative 9.8. I get, oh, is it 12 seconds even? Yep. Oh, square root of 12. I would have forgotten. I'm in a slump. 3.46 seconds. I'll go to 3 sig figs. This last part here, part C, I had to make a guesstimate. I was looking at the video and guessing how deep the river was. Probably, because you were asking about this, probably the river was deeper. What I was trying to do was think about what if you had done this into a pool, which has a depth of about 3-4 meters, okay? Which would be foolish to do. So what was the acceleration? We got a distance. You know what? I think I'm going to go A equals VF squared minus VI squared all over 2D. I guess I could, well, no, you know what? I'm going to use VF no matter what, right? Then, or you could go A equals VF minus VI over T. If I'm going to use one calculated answer, I may as well commit and use 2 calculated answers. And I got both of them here. I'm going to use this method. So I'm going to go negative 33.9482. That's a lot of sig figs. That should keep me fairly accurate. Minus VI was 0, divided by, and I'm going to use my answer button cleverly. Let me make sure I'm doing this wrong, Mr. Dewick. Hang on. Hang on. You're right. V final is 0. V initial is going to be negative 39. That's because that's now when he hits the water, Dewick. So it's going to be 0 minus negative 33.9482. 2 divided by answer button. Is that right?
Yeah. Oh,
That's not right.
that's not what I got at all.
I've done something wonky here. I'm going to be really cheaty and I'm going to do this. Hang on. I'm going to go back a few spaces to, oh heck, 2 times negative 9.8 times negative 58.8 square root, and then make it negative. There's the velocity when you hit the water, right?
Yeah.
So that's going to be V final is 0 squared minus that number squared divided by bracket 2 times negative 58.8.
Oh, it's 3.5. Because that's how deep water.
Thank you. Tato, I'm in a slump here. 3 point. Wow. Is that what you get?
There you go.
So now I got to figure out why I didn't get that with the other one. Negative 164 meters per second is 164, 165.
It should be positive.
Oh, because you know what? He's slowing down. So you could argue it was negative, but he is accelerating upwards. You could argue it was positive. So I'll go 165 meters per second squared. Let me try it the other way. So it's going to be 0 minus negative. Oh, you know what? I don't know time. I can't use this method. That's the time of falling, not the time of stopping. That was dumb of me. I have to use that one. Wow. How many G's did the jumper experience while in free fall? This is easy. 1. Because free fall. You know what? I'm going to go answer clear. Answer button divided by 9.8. Do you get that many G's?
G's can't be negative, right?
They can be. All that means, so we have to talk about what you mean by a negative G. In roller coaster design, positive G's are, let me get this right. Positive G's make you feel heavier. Negative G's make you feel lighter. And our brains are much better at dealing with positive G's than negative G's, because all of you have gone on swing sets as a kid, and at the bottom of a swing set you're experiencing positive G's, so that doesn't freak you out. There are no playground rides where you experience negative G's very often, which is why on the elevator you really freak out when it goes down and you start to feel lighter and you feel like you're going to fly out of your seat. You're not, but you feel like it because you feel lighter. I got a video of this. Put your pencils down. Give yourself a score out of 65, but I got a video of this. On your study guide, I did put a couple of questions that I didn't put on your most recent quiz. For example, number 7, here's what I meant where I said on your test, I will give you at least one question where I give you numbers in kilometers per hour and a time in seconds, because that's the easiest to measure. Convert your velocities to meters per second, something to do with a 3.6. There is a couple of questions where I'm going to ask you how many G's of acceleration. Weil asked, Mr. Dewick, why isn't it negative or positive? I'll be honest, when it comes to how many G's, I won't be that fussy on the sign, on the negative or positive. And it's because a negative G in free fall is different from what's meant in the industry by negative G's on roller coaster rides or even in crash tests. So as long as you get the magnitude right, I'll give you full marks. Okay? Somebody had a question from here. They were asking about, which one? Number 4. So you're going to use this. This is the ugliest one, which I hardly ever use, by the way. I'm purely throwing it in there as an exercise in formula manipulation. It honestly doesn't show up in word problems. I can't think of a word problem. I could, but it'd be a stupid one. What are you trying to get by itself? What's going to drop down like a domino? And then I think I'm going to minus the 0.5 AT squared over, because it's adding, and then divide that whole mess by a T, and apparently that's VI. Ryland, don't think we've ever done that in Physics 12. Like, I throw it in Physics 11 to kind of say, by the way, you can handle it. But in Physics 12, when we're actually looking at situations, I can't recall a single time where we knew the distance, the acceleration, and the time, and didn't know what we started at in a real-life problem. that okay?
Yes, thank you.
Okay.